Skateboarding is a popular sport enjoyed by many around the world, and a crucial component of any skateboard is its wheels. In this article, we will take a closer look at how skateboard wheels are made and also explore CO2 scrubbers, which are used in many industrial applications to reduce carbon emissions. Skateboard wheels are made using a process called injection molding. This process involves melting down a specific type of plastic called polyurethane and then injecting it into a mold. The mold is made from metal and is specifically designed to create the desired shape and size of the skateboard wheel. Once the plastic is injected into the mold, it is left to cool and solidify before being removed. The polyurethane used to make skateboard wheels is a type of plastic that is ideal for this purpose due to its durability, resistance to abrasion and shock, and ability to grip onto surfaces. It also allows for customization, as the hardness of the plastic can be adjusted to suit the user's preferences. The process of making skateboard wheels involves several steps, including mixing the polyurethane with a colorant and any other additives, pouring the mixture into the injection molding machine, and then setting the machine to the appropriate temperature and pressure. The plastic is then injected into the mold, and once it has cooled and solidified, it is removed from the mold and inspected for quality. The quality of skateboard wheels is crucial, as the wheels are subjected to a lot of wear and tear, particularly when performing tricks. Quality control measures are therefore essential to ensure that the wheels are up to standard. Inspections may include checks for defects such as air bubbles, cracks, or uneven surfaces. CO2 scrubbers are devices used to remove carbon dioxide from the air or other gases. They are commonly used in industrial applications to reduce emissions and to maintain safe working conditions. CO2 scrubbers work by passing air through a solution of chemicals that react with carbon dioxide, removing it from the air. The chemicals used in CO2 scrubbers vary depending on the specific application, but they typically include a base such as sodium hydroxide, which reacts with the carbon dioxide to form a salt. Other chemicals may be added to enhance the process, such as amines, which can selectively remove carbon dioxide from a mixture of gases. CO2 scrubbers are an important technology in the fight against climate change, as they can help to reduce the amount of carbon dioxide that is released into the atmosphere. They are also essential in many industrial processes, such as in the production of chemicals and the processing of natural gas. The design of CO2 scrubbers varies depending on the application, but they typically consist of a vessel containing the chemical solution in a system for passing air or gas through the solution. The efficiency of a CO2 scrubber depends on several factors, including the design of the vessel, the type and amount of chemicals used, and the flow rate of the air or gas. One challenge with using CO2 scrubbers is that they require a lot of energy to operate, particularly if they are used on a large scale. However, advances in technology have led to the development of more energy-efficient scrubbers, and research is ongoing to improve their performance and reduce their environmental impact. In conclusion, the production of skateboard wheels involves a complex process that requires careful attention to detail and quality control measures. Polyurethane is the material of choice due to its durability and versatility, and injection molding is the preferred method of production. CO2 scrubbers are essential devices that are used to reduce carbon emissions and maintain safe working conditions in many industrial applications. The chemicals used in CO2 scrubbers react with carbon dioxide to remove it from the air or gas, and their efficiency depends on several factors. While energy consumption is a concern when using CO2 scrubbers, advancements in technology have led to the development of more energy-efficient scrubbers, which is a positive sign for the future of this technology. One way to reduce energy consumption in CO2 scrubbers is to use renewable energy sources to power them. For example, a scrubber could be powered by solar panels, wind turbines, or hydroelectric power. This would not only reduce energy consumption but also reduce the environmental impact of the scrubber. Another way to reduce energy consumption is to improve the design of the scrubber. For example, some scrubbers use a rotating packed bed to increase the surface area of the chemical solution, which increases its efficiency. Other designs use membranes to separate the carbon dioxide from the air or gas, which can also improve efficiency. One area of research that is currently being explored is the use of enzymes to remove carbon dioxide from the air. Enzymes are proteins that catalyze chemical reactions, and some enzymes have been found to selectively react with carbon dioxide. This could potentially lead to a more efficient and environmentally friendly method of carbon capture. Another area of research is the use of artificial photosynthesis to capture carbon dioxide. This involves using sunlight to convert carbon dioxide into a usable form of energy, such as hydrogen or methane. While this technology is still in the experimental stage, it shows promise as a way to not only capture carbon dioxide but also produce energy. In summary, CO2 scrubbers are an important technology for reducing carbon emissions and maintaining safe working conditions in many industrial applications. While they do require energy to operate, advancements in technology are leading to more energy-efficient scrubbers. Renewable energy sources and improved design are two ways to reduce energy consumption, and research into new methods of carbon capture, such as using enzymes or artificial photosynthesis, shows promise for the future. As the world works to reduce carbon emissions and combat climate change, CO2 scrubbers will continue to play an important role in these efforts.